So today we'll be talking about Chapter 9, Section 1, and the title of this is The Market Revolution. We'll be talking about several technological changes. These changes brought about even greater interaction as well as more economic diversity among the regions of the nation. So we'll be talking about several different exciting inventions to start us off.
For the past 5 years, I've been investigating this question of where good ideas come from. It's the kind of problem I think all of us are intrinsically interested in. We want to be more creative, we want to come up with better ideas, we want our organizations to be more innovative. I've looked at this problem from an environmental perspective. What are the spaces that have historically led to unusual rates of creativity and innovation? And what I've found in all of these systems, there are these recurring patterns that you see again and again that are crucial to creating environments that are unusually innovative. One pattern I call the slow hunch, that breakthrough ideas almost never come in a moment of great insight, in a sudden stroke of inspiration. Most important ideas take a long time to evolve, and they spend a long time dormant in the background. It isn't until the idea has had 2 or 3 years, sometimes 10 or 20 years to mature, that it suddenly becomes accessible to you and useful to you in a certain way. And this is partially because good ideas normally come from the collision between smaller hunches, so that they form something bigger than themselves. So you see a lot in the history of innovation, cases of someone who has half of an idea. There's a great story about the invention of the World Wide Web in Tim Berners-Lee. This is a project that Berners-Lee worked on for 10 years. But when he started, he didn't have a full vision for this new medium he was going to invent. He started working on one project as a side project to help him organize his own data. He scrapped that after a couple years, and he started working on another thing. And only after about 10 years did the full vision of the World Wide Web come into being. That is, more often than not, how ideas happen. They need time to incubate, and they spend a lot of time in this partial hunch form. The other thing that's important when you think about ideas this way is that when ideas take form in this hunch state, they need to collide with other hunches. Oftentimes, the thing that turns a hunch into a real breakthrough is another hunch that's lurking in somebody else's mind. And you have to figure out a way to create systems that allow those hunches to come together and turn into something bigger than the sum of their parts. That's why, for instance, the coffee house in the age of the Enlightenment, or the Parisian salons of modernism, were such engines of creativity, because they created a space where ideas could mingle and swap and create new forms. When you look at the problem of innovation from this perspective, it sheds a lot of important light on the debate we've been having recently about what the internet is doing to our brains. Are we getting overwhelmed with an always connected, multitasking lifestyle? And is that going to lead to less sophisticated thoughts as we move away from the slower, deeper, contemplative state of reading, for instance? Obviously, I'm a big fan of reading, but I think it's important to remember that the great driver of scientific innovation and technological innovation has been the historic increase in connectivity, in our ability to reach out and exchange ideas with other people, and to borrow other people's hunches and combine them with our hunches and turn them into something new. That really has, I think, been, more than anything else, the primary engine of creativity and innovation over the last 600 or 700 years. And so yes, it's true we're more distracted. But what has happened that is really miraculous and marvelous over the last 15 years is that we have so many new ways to connect and so many new ways to reach out and find other people who have that missing piece that will complete the idea we're working on, or to stumble serendipitously across some amazing new piece of information that we can use to build and improve our own ideas. That's the real lesson of where good ideas come from, that chance favors the connected mind.
Okay, first off, in the early 1800s, farm families were largely self-sufficient. They could only buy what they couldn't make. Generally, families could make most everything they needed. They couldn't make wagon axles. They couldn't make some tools, but otherwise they could produce all the food they needed. They could make repairs to their home from trees that they cut down. They could make all of their meals from food that they had produced. If someone got sick, they might need to go see a doctor. But families typically had very little money, and so generally they tried to provide for their own. In the mid-1800s, farmers began specializing, meaning they would raise one or two crops for income instead of being subsistence farmers, which is what we call self-sufficient farming families. Subsistence means they would grow enough to survive and would typically not grow enough to earn an income. But by the mid-1800s, many farmers were able to clear large enough plots of land with several technological innovations that we'll be talking about today. They were able to farm enough property to grow enough, even with an individual family, to earn an income off of it. Now, with this income, farming families were able to afford to begin to purchase items that were made by others. And we call this a market revolution. Again, when we see that word, that means a profound change. And when I'm talking about farming families, I'm talking about most people in the country, because most people were still farmers at this time. And with these new inventions that we'll talk about today, they were significant enough that people were able to begin to buy things instead of just making enough to survive and living off of the land. So, several things that make this possible. Number one is an entrepreneurial spirit. That is the opportunity to get rich. Why did John Deere invent the steel plow? Why did Cyrus McCormick invent the mechanical reaper? Why did Samuel F. B. Morse invent the telegraph? Why did I.M. Singer invent the foot treadle for the sewing machine? Why did these people do these things? It wasn't out of the good of humanity. John Deere wasn't just thinking, I bet Jordan's ancestors are going to want to be able to farm lots of land. It wasn't out of a spirit of goodwill. John Deere became immensely wealthy. In fact, that one invention set him for life, so he would never have to work again. Cyrus McCormick the same. He invented a device that allowed one farmer to do the work of several farmers with a machine. Why did he do it? Again, it wasn't out of goodwill. It was so that he could get rich. That's what we call an entrepreneurial spirit, and that is the essence of capitalism. That, why are you here? You're here to get a good education so that you can get a good job. So that you can become a better person, sure. But it's self-motivation that makes you strive for betterment. That's capitalism. That you, motivated by your own self-interest, are going to do great things. But that also helps everyone. Because maybe you're going to be an excellent doctor. Maybe you're going to be a great lawyer. Maybe you're going to be a professional of some kind or a business person. And whatever it is you do, the fact that you're going to be great at it is going to be good for everyone. You're out to help yourself. But ultimately that helps us all, because Carly's going to go out and be rich and famous, and she's going to pay lots of taxes. And those taxes will provide for the roads that you drive on, for the medical care that you receive, for the education that your children will someday receive, for all the public goods and services will be paid for through the taxes that Carly is going to pay by someday being rich and famous. Now, if she weren't rich and famous, she would still pay taxes, but she'll pay more taxes if she goes on to be rich and famous. Again, providing for more goods that benefit the whole community. So, capital is another word for money. But it's not just money. Capital means the money the property, the machines, the tools necessary to generate income. So what do we need within a business to generate income? Well, first off, we need a location. Even if your business is online, you still have to have a location which to conduct your business. That would be property. Secondly, we have to have income. Even if your business is online, you still have to generate an income so that you can pay your bills. And then finally, machines, the tools with which to do your business. We call those things capital, generally in an economic term, and capital fuels a growing economy. An entrepreneur is someone who uses their own capital to generate profit. If Michaela has a business idea, maybe it's something in web design, maybe it fills a niche within her interest. So let's say that she has an interest in anime, and she just loves anime. And she can draw it, she can manipulate it, and that's her thing. Well, she could turn that into a business. Maybe she creates a website design company that can develop anime-themed templates for websites. And she can begin to draw these templates using graphic design, and she can contract these out for companies. She could start doing that now. She could generate income now. Doesn't have to wait till she gets a degree. By the time she finishes school, she could be earning a sizable income off of her side business. She would be an entrepreneur. Because to start, she would have to use her own resources, her time, her money, her energy. She would yield off of the product of her work, her time, her labor, her resources, her energy. Off of the product of her labor, she would yield profit. She's not going to do it for any of your sakes. She's going to do it for her own. But she will have to pay taxes on that income. And those taxes will benefit all of us. Now again, an entrepreneur, which by the way is a French word, it means to undertake, is someone who undertakes an endeavor for their own profit. Any of you can be an entrepreneur. Most businesses will require some investment capital, meaning that in most cases you will have to go to a bank to get a loan, because many businesses will require a location to operate within. And most businesses cannot be operated out of your home, yet some can. The web design business, sure. Any type of online commerce, sure. But if you need a physical location, perhaps you will need capital. And that benefits a whole lot of different people. Because you will go to the bank, they will issue a loan, they will receive a profit, they will take those profits and put them into further investments, i.e. more home loans, more business loans. And so an entrepreneurial spirit does benefit the whole community. That's the essence of capitalism. Now, a number of new inventions spurred by entrepreneurs developed a lot of new profits for the inventors and new products for the consumer. For example, Charles Goodyear did not invent rubber, yet he invented a process called vulcanization that could make rubber useful. Rubber literally grows on trees. It's a form of sap that is a malleable substance when it dries. But yet, if you take that same substance and you take it through the process of vulcanization, well, then it's the rubber on our shoes. It's the rubber on your tires. It won't melt in heat because sap will turn back to sap. if it's hot enough. Rubber won't melt until it reaches a burning temperature. Unvulcanized rubber will also freeze and become brittle. Your shoes will be fine unless it reaches a very severe temperature in which you're not likely to see. Your tires will be fine unless it reaches Arctic level temperatures, in which case rubber's not going to be great out there. Another inventor, and again, these people became very wealthy doing what they did. Elias Howe patented the sewing machine, providing for the domestic mechanization of textile production. It's a fancy way of saying now people can make clothes at home much faster than the old hand sewing treadle. And I.M. Singer developed the foot treadle. You see, the sewing machine was invented long before electricity was available for home consumption. And so the sewing machine was a hand-cranked device. I.M. Singer perfected that device with the foot treadle, because instead of it taking two people to operate, one to crank by hand, one to operate the machine, now one person can pedal and make clothing at the same time. Of course, these two people became rich. In fact, if you buy sewing materials today, you will see one of their two names on those products still today. Yeah. This made the factory production of clothing possible. This made home production of clothing possible. In fact, this benefited everyone because the price of clothing dropped so significantly that clothing became affordable for the average person. And so we're talking about a market revolution here, where people stopped making clothing by hand and started buying it in stores because it was now practical to do so. This has a great impact on the household economy. For example, farmers began using mechanized farm equipment to boost industrial output. For example, the mechanical reaper that I'll show you in just a moment is a form of mechanization. Why use a mule when a mule can get old? A mule has to be fed. A mule can get tired and only work a certain amount. Oxen can be difficult to work with. Horses are better, but they require a lot of overhead and care. A machine merely needs to be cleaned and taken care of. And yeah, fuel will come later when we get to like combustible engines and so forth. But at this time, a machine only needs to be cleaned and fixed if it breaks. It doesn't complain. It doesn't get hungry. But a machine can outwork a human or an animal. These mechanical reapers increased a farmer's output 8-fold. This is good for the farmer. This means that a farmer can operate a larger tract of land with less labor. As a business owner, a farmer can produce more capital with less expense thanks to mechanization. From the consumer end, a farmer can produce more with less. They can translate that to savings for the consumer thanks to greater volume. So in the end, mechanization helps us all. It helps the farmer make more money. It helps us save money. So here's a photograph of one of the earliest sewing machines developed by Elias Howe. So the machine here, developed by Elias Howe, but you see down here the foot treadle, which powers the machine, allows this one individual to create clothing far quicker than they could by hand. The next invention I'd like to show you the telegraph. In 1837, Samuel F.B. Morse developed the very first electronic communication. Every time you send a text message, it is part and parcel thanks to Samuel F.B. Morse. The electromagnetic telegraph allowed messages to be tapped in code, carried by copper wire, to be transmitted across long distances. Because what Samuel Morse was able to harness was electrical current. Electrical current, as we know, travels through conductors. Copper is an excellent conductor of electromagnetic current. And that current creates a signal, a very faint signal, a noise that you can hear. If you stand under a transformer, you hear a buzzing. And that buzzing is a large amount of current passing through a conductor. But you can create the same sound if you amplify it through a small amount of current. And if you stop that current in a pattern, you can communicate. He developed a code, named it after himself, Morse code. And with that code, a series of taps, both fast and small, you can interrupt the code in a pattern and you can communicate. I'm sure you all know what this one means. Anybody? Any Boy Scouts, Girl Scouts in the room? SOS, very good. SOS is the international symbol for help. If for some reason you cannot get a message out or you cannot communicate, this very simple device can get a message out over long distances. If you're stranded on the beach, put SOS, and anyone will recognize that in any language. If you can develop a method of communicating, did I do it backwards?
Yes,
Dot,
you
dot,
did.
dot, dash, dash. Okay. Yeah, I couldn't remember. So yeah, it's... And again, this technique can be communicated in so many different ways. It's a series of sounds. You know, for example, if we needed to communicate with the neighboring classrooms, so if we needed to get to a message to the computer lab, see if somebody comes in. That's SOS. Now, I did that with a series of sounds. What makes Samuel F.B. Morse famous and what made him rich was he was able to do that across long distances through electrical current, because his device that you see here interrupts the electrical current. Every time he presses down the handle, it stops the current. If he presses it down and quickly releases it, that's a dot. If he presses it down and holds it for a second, then releases, that's a dash. With that simple binary system, he was able to develop a code called Morse code and communicate. Does anybody know what the very first message sent electronically was? Yes?
I don't remember it.
That's okay.
I thought you meant from ships.
No, the very first message that Samuel F.B. Morse sent. It's okay if you don't know. Well, he knew he was going to be famous. He knew he had had a breakthrough, that he was going to be rich, that this was going to change the world. So he thought of something really profound to say. And the first message he sent electronically is, "What God hath wrought." He was thinking of Pandora's box that he had just opened, this big, that he had just changed the world. And in many ways, he did. In fact, his device was patented in 1837. By 1854, there were 23,000 miles of telegraph cable that had crossed the entire country. In fact, by the end of the 1800s, there will be a telegraph cable under the Atlantic Ocean connecting the two continents. And the telegraph is going to change history in a big way. But next, let's talk about transportation. The steam engine, which I've got a video here of the steam engine to show you. The steam engine had a profound impact on transportation. Because you see, heat can be harnessed. Electric current represents energy. Heat is a form of energy. The greater the heat, the more energy you have. But the question is how to harness this to create combustion. And the inventor of the steam engine, not an American by the way, but we'll talk about how Americans use this to create some innovations of our own. But the inventor of the steam engine was able to harness the power of heat by using heat to create pressure. By heating up water, water turns to vapor. That steam, under pressure, creates energy. And if that energy is harnessed, it can create combustion. So if you allow that steam to escape pressure and then place a mechanical device to spin as the steam escapes, that creates combustion. And you can propel a craft that way. Now, Robert Fulton, a wealthy business person, purchased one of these steam engines, had it installed on a boat, and his steamboat was able to go up the Hudson River. Up the Hudson River. It wasn't fast. In fact, it took 32 hours to go 150 miles. But he was able to go up the Hudson River. Previously, this had been made possible by people paddling and going up a river, even as slow as the Hudson River, by paddle or by sail, would be difficult at best, if not impossible. But this man proved that it could be done in a predictable time, consistently, using the steam engine. By 1830, steamboats on western rivers were commonplace. They cut down the cost of shipping, they sped up the cost of transport of cargo and people, and water transport became key for moving heavy materials and raw materials, heavy machines. The Erie Canal, which connected the Great Lakes to the Atlantic Ocean, was heavily used, and it allowed lowering of cost, the construction of more canals. Effectively, what the steam engine did was allow the transport of freight upriver, where previously goods could only be shipped downriver. I mean, it's huge. And canals also connected Midwestern farms to northeastern markets. And so really what we're talking about here, folks, is a greater means of transportation and a greater means of development for economic prosperity.
The rising prosperity that accompanied industrialization also brought improvements in transportation. First, the roads, that in the past were often little better than crude muddy tracks, were improved to handle more traffic. And new bridges were constructed, some made entirely of iron for the very first time. As early as 1761, an intricate system of canals and locks began to be constructed, so that barges could carry fuel and raw materials from mines, factories, finished goods from factories to city warehouses. As early as 1825, steam engines were being used to turn the wheels of locomotives, moved along steel tracks at the unheard-of speed of 15 miles per hour. Also by that time, steam-powered ships were beginning to travel the seas, no longer dependent on the ever-changing winds. And in the 19th century, huge parts of North America and Europe completed their transition to an industrial society. Steam-powered farm machines, from tractors to hay balers, revolutionized farming. And by the start of the 20th century, the United States had overtaken England to become the world's leading industrialized nation.
Now, railroads operated using the steam engine. But unlike the simple contraption that we just witnessed, trains required much more combustion, equivalent to that of what the steamships used. And while trains moved slowly at this time compared to trains or cars today, we're talking 15 miles an hour. And while shipping by railroad was much more expensive than shipping by boat, it was faster. Also, railroads could operate in winter, and they could go overland. Previously, the transportation of freight could only be accomplished by river, and generally goods had to be shipped downriver. And so farmers and settlers were limited to movement along big rivers. But now, goods can be shipped over land, and they can be shipped year-round. It's huge. Now, train travel at this time was rather uncomfortable. Shocks weren't very good, so passenger travel by train, certainly uncomfortable. But it was possible. It was possible for people to move overland now instead of having to walk, instead of having to take a wagon, which could take months at a time. They could take a train, which can travel consistently and predictably over long tracts of land. And again, it cuts down the cost of travel. It cuts down the time of travel. It also cuts down the cost and time of freight, which helps the economy.
Once steam trains were proven to be an efficient way to move people and freight, businessmen began to build tracks for them to run. George Stephenson built the world's first public railroad in 1825. The Stockton and Darlington ran for about 20 miles and 32 kilometers, and was the first to carry freight on a regular schedule. Stephenson also built the first passenger railroad in England. It opened in 1830 and ran between the towns of Liverpool and Manchester. In America, it was the barge and canal companies that had the money and the knowledge to build the first railroad. The Delaware and Hudson Canal Company purchased an English-built steam locomotive, the Sturbridge Line, in 1829. It was the first full-size locomotive to operate in North America. A year later, the Baltimore and Ohio Railroad was first in America to carry passengers. In the beginning, the B&O's trains were drawn by horses, like their canal barges, but they experimented with a rail car powered by a sickle. That experiment failed, and in 1831 they began carrying passengers behind a steam locomotive called the York. By 1835, over 1,000 miles, that's 1,600 kilometers of track had been laid. More than 200 separate railroads connected towns and cities in 11 eastern states. By the end of the 19th century, thousands of trains made their way across the largest transportation network the world had ever known. Railroads were the biggest business in America, and because they made moving between cities and factories and farms so easy, they also made nearly all other businesses possible.
Okay, so the effect these inventions had. Number one, they improved transportation. With trains, with steamboats, you could now travel much more quickly and much more easily. Devices like the telegraph improved communication. Now people can communicate instantly through telegraphic messages, whereas previously you would have to communicate only by letter, which could take weeks or months to travel between. And what this did to us as a country was it connected regions of our country. Henry Clay envisioned a society where we would be so connected, both economically and personally, that we would have no need to go to war with one another. And his hope with the American system was that by connecting our regions economically, personally, and politically, that we could be a united states instead of a divided one. But technology made this possible in a way that Henry Clay could have only dreamed of. In fact, today, technology is globalizing our world, connecting countries that had once been enemies and making them now business partners. And in many ways, that's what the telegraph and the steamboat did for our country. For example, by 1838, the very first national highway, called the National Road, extended from Maryland all the way to Illinois. And these growing links connect different parts of our country. The South, however, did not develop the degree of infrastructure that the North did. There were far fewer railroads, far fewer canals, far less technology in the South, because most people who were investing in the North in technology were making money that way. But in the South, so much money could be made off of cotton, there was no need to invest in technology. You could invest and receive a greater yield on your investment in the South on agriculture than you could in technology. More money to be made on cotton in the South than there was on technology. And so the South lacked the capital to invest in factories, because anyone who did have capital was investing in agriculture because more money there. Most of the money was tied up in land, in slaves, relying on cotton, tobacco, and... But the Northeast, as a result of this technology, became a center for American commerce. For example, New York City became the central link between U.S. farms and European markets. And so the great rise in manufacturing was centered around the northeastern United States. Our factories could produce more, better, and less expensive goods. The factory system allowed us to produce in great volume. And that translated into lower cost for the consumer. Innovations in regards to farming. John Deere made an improvement on a device that had been in use for thousands of years. Folks, if you want to never work again, you make an improvement on a device that had been in use for a very long time. If you can change the world, you will never have to work again. That's what John Deere did. Again, motivated by profit, sure. But when he introduced the steel plow, previously plows had been made of iron. Iron is a soft and malleable metal. It loses its edge easily. Steel is a much harder substance. A steel plow can cut through rocky soil. So effectively what he did was allowed farmers to grow crops in places they previously could not grow crops.
Iron hits like a really hard rock, it can break, but...
With this, farmers could replace oxen with horses. Horses who can plow much faster and are more reliable and don't have to pull as hard as oxen, because steel can hold a sharper edge for a longer time. Another one of these big innovations, Cyrus McCormick invents the mechanical reaper. As I said previously, one farmer could do the work of 5 farmers. Ladies and gentlemen, that is a huge innovation. Because if one farmer no longer has to hire 4 people to help him, that's 4 people's income that farmer gets to put in the pocket and keep. That's more money for the farmer. That translates to cheaper crops, better for consumers, better for the economy in general. And these 2 devices allow farmers to shift from subsistence farming to cash crops. Because think about this, before the mechanical reaper, farmers used a scythe. This is a scythe. This is a hand reaper, a tool farmers would use to bring in the sheaves, to bring in grain. It's back-breaking work. They would do this all day long, cutting grain by hand, all day long. Back-breaking work, and it's a slow process. The mechanical reaper does that automatically. So here's a drawing of one of these mechanical reapers. Instead of the scythe, you can now do it automatically. And that's in the 1830s. That's a big deal. And so here we see a drawing of the mechanical reaper in use on this farm. Farmer's still located near rivers because the steamboat provided excellent shipping for freight. But this man can now sit as horses pull this reaper, which harvests his crops automatically. Okay, now I think that's it for our section.